So in this video, we will understand the definition of a cycloid. So before we start understanding the definition of a cycloid, you need to know what is a locus. Locus is the path traced out by a point or a curve generated by a point when that point is moving in space according to a specific geometrical condition. So there is a condition which needs to be satisfied by the point P. So if I take an example, the best example for locus is a circle, because if I consider there, so in our definition for locus, I said a point is moving in a particular path, so that point is P. Here this P is a point on the circumference of the circle actually, but consider the circle is not available here. Circle is not available here. Just consider a point P. Point P is on this line. So this is the floor. Okay, this is the floor or the ground. So P is on the ground. The point P is moving with a condition that the distance of this point from a fixed point is constant. That means the distance between the point C and the point B is constant. So if I take a point C somewhere here, so the distance between CP should be same. That is a condition. The distance between the fixed point and the moving point should be equal. Okay, so that means point C so point C and point P. P should be moving in the direction or in a path with the condition the distance between C and P should be same. So if I draw from here, if I draw a line, this distance CP would be some value. From the same point, if I draw another line here such that the distance between C and the point P is again same, equal distance. If I draw another line with the same distance again, so what are these lines? These are the lines drawn with the same distance that need to be maintained. So CP is the distance should be maintained, it's a condition. So this is also point P, this is also point P, this is also point P, this is also point P. All these points are the positions of the point P when it is moving in a particular path with the condition being satisfied. So the condition that is being satisfied here is the distance between C and P should not change. So when I locate all those points, so these will be the points of or the intermediate locations of P. So when I join all the points in the sequence, you will get a circle, right? Okay, so circle is the best example for locus. This curve generated or the path that is traced by this point is the locus. That locus has been given a name as circle, right? So this is your locus. So what is the definition of a cycloid? Cycloid is the locus of a point P taken on the circumference of a circle when the circle rolls on a straight line path without slipping. So for suppose if this circle is slipping, so when this circle slips from this position to this position, so when it is rolling, the circle will be changing its position, right? So after rolling for certain distance, the position of the circle would be somewhere here. Even though the position of the circle has changed, the position of the point P will not change if the circle slips. So if it is just slipping, point P will be on the ground only. Point P will be here only because it is slipping, it is not rolling. So for the cycloid, slipping should not happen. That is why that condition has been included in the definition for cycloid. To draw the locus of that particular point, I will be considering intermediate positions of the circle when it is rolling. For our example, I will consider that the circle is rolling in clockwise direction for 1 revolution. Considering the position of the center of this circle with respect to P, this position as 0 degrees. So when the circle starts rotating, so from here to here, when the point P moves from here to here, this would be 90 degrees. Here to here, this will be 180 degrees. And this would be 270 degrees. And finally, 360 degrees. That means when the point P covers an inclination of 360 degrees, that means the circle has rotated for 1 revolution. Right? So in our example, I am considering the circle is rotating in clockwise degrees for 1 revolution. That means in 1 revolution, the position of the point P changes, and after 1 revolution is completed, again the point P will come and touch the ground because it is traveling the 360 degrees inclination. So the point P taken on the ground will again come and touch the ground. That's why P is the initial point on the ground on the circumference of the circle. P dash is the final point on the ground on the circumference of the circle. Actually the point is on the circumference of the circle. Because it is touching the ground, I have located the point here. When the circle rotates for 1/4 revolution, this is the position of the circle after it has been rotated for 1/4 revolution. Then on this circle, where would be the position of the point P? It will not be on the ground, right? So if the circle has rotated 1/4 revolution, 1/4 of 360 is 90 degrees. So from here, the point P has changed its position to here. Now this is your point P, some intermediate position P1. Again the circle rotates for another 1/4 revolution. 1/4, another 1/4, half, another 1/4, 3/4. So when the circle is in this position, where would be the position of the point P? 360 degrees into half revolution. So 360 into half is 180 degrees. So if this is the initial point P, exactly 180 degrees means exactly opposite point. This would be your point 2, P2. Again after the circle rotated for another 1/4 revolution, that means now the circle has rotated 3/4 revolution. So the position of the point P will be 360 into 3/4, 270. So if this is the initial point, 90 degrees, 180 degrees, 270 degrees. This will be your point P3. So P is the initial point, P1, P2, P3 are the intermediate points, and P dash is the final point, the final position after the circle has rotated for 1 revolution. Now what is the cycloid? It's the locus, right? Locus of what? Locus of the point P. Locus of the point P. The point P has travelled in a path P, P1, P2, P3, P dash. That is the path. That is the path traced by the point P, which is taken on the circumference of the circle when the circle rolls on a straight line path without slipping. So just join all the points like this. I have joined all the points in the path. This is your locus. Similarly, this is the path traveled. Join all the points. P, P, P1, P2, P3 and P4. This is your cycloid.